Hello guys, this is example number 3 involving particles and objects with externally applied forces and acceleration. So such examples are solved based on Newton's laws of mechanics. Before approaching this example, let's illustrate a very important concept that is the basis for solving problems involving objects with applied forces and acceleration. The concept is related to the axis and direction of applied forces. Consider the following x-axis to the right. This is x prime, where O is the origin and the axis is directed from x to x prime. Then consider the following object, say it is a box. This object has a mass, which is m kilograms, and the acceleration of this object, the box, is a meters per second squared. Assume that there are several forces acting on this box. Say there is the force R to the left and the force P to the right. Those forces act along the x-axis, meaning that they are parallel to the x-axis, so we say along. Then, according to Newton's second law, we know that F is equal to ma. But what is F exactly? And how can we relate it to the applied forces R and P? F is the resultant force in the direction of the considered acceleration. So we should consider an acceleration. We should consider a direction of motion at first to understand what is F and what is the acceleration A. So if the acceleration is parallel to the x-axis, then it is along the x-axis with its direction to the right. Thus, the positive direction for summing up forces along the direction of motion is the direction of acceleration, which is also, in this case, the direction of the x-axis. Then the resultant force is the summation of the two applied forces in the direction of acceleration, which is along the x-axis directed to the right. So the positive direction, while we sum up forces, is the same direction as the acceleration. It is to the right. In this case, we have R and P along the x-axis, where R is opposite to the positive direction of the acceleration, while P is in the same positive direction of acceleration. Thus, the resultant force F in the equation of Newton's second law is P, which is positive in the positive direction, minus R, since it is in the negative direction, so it holds a negative sign, and this is equal to ma. So we can say that the resultant force F is the summation of forces along the positive direction of motion, which is the direction of the acceleration of the object A that is at the right side of the equation. Similarly, if we are considering forces in motion along the y-axis, if we apply Newton's second law, then the resultant force along the y-axis, or parallel to the y-axis, is the summation of forces along the y-axis, which is equal to the mass of the particle multiplied by its acceleration along the y-axis. This is the right side of the equation, where the positive direction for summing up forces is in the direction of the present acceleration along the y-axis. This should be cleared out when approaching problems with objects with applied forces along several directions. So we only sum up forces acting along the same axis, and this summation is equal to the mass multiplied by the acceleration along the same axis, where our positive direction is the same direction as the acceleration. Then let's go back to example number 3 to apply this concept and understand it well. This example states the following. In each of these diagrams, the body is accelerating as shown. So we have two diagrams, A and B. In each diagram, there is an object that is accelerating as designated by the acceleration vector above each object. So this is clear enough. We are asked the following. Find the magnitude of the unknown forces x and y. As you can see, there are two unknown forces in addition to the known forces acting on the objects in diagrams A and B. Let's analyze the first free body diagram in A. The mass of the object is 2 kilograms. So to use Newton's second law in the direction of acceleration, we have the 2 kilograms mass and the acceleration 2 meters per second squared. This is the right side of the equation. Then the first force along the horizontal axis, which is the axis of acceleration, is 4 newtons directed to the left, opposite to acceleration. The second force along the horizontal axis is x, the unknown force, directed to the right. Well, then along the vertical axis, there is the force y, which is an unknown, that is directed upwards. And finally, along the vertical axis too, there is the force 2g newtons directed downwards. This is the gravitational force or the weight of the object. So to calculate x and y, we shall use the equation of Newton's second law, which is F net equals to ma. So we should first determine the positive direction along the horizontal and vertical axis, or respectively the x and y axis. Along the x-axis, the positive direction is along the present acceleration, while along the y-axis, the positive direction is set by us to be upwards. Now let's apply Newton's second law of mechanics, as we've illustrated earlier. First, let's apply this along the x-axis. Then along the x-axis, F net, the net applied force, is equal to ma. Along the x-axis, there is the 4 newtons force, that is negative since it is directed opposite to the positive direction of the x-axis. And there is the unknown force x, which is positive since it is directed in the positive direction of the x-axis. Those two are the only forces acting along the x-axis. So we end up with minus 4 plus x, that's equal to ma, mass multiplied by acceleration. Mass is 2 kilograms multiplied by a, which is 2 meters per second squared. Then there is minus 4 plus x, that's equal to 2 multiplied by 2, which is equal to 4 kilograms multiplied by a meter per second squared, which is in Newton. So we have 4 newtons. Then to find x, we move the negative 4 to the right side. Then x is equal to 4 plus 4, which is equal to 8 newtons. And that's x. Next, to find the force y, let's apply Newton's second law along the y-axis. Knowing that the positive direction along the y-axis is upwards, then let's check the forces along the y-axis and sum them up. So in this case, we chose the upward direction since the unknown force is acting upwards. So F net is equal to ma. There is y, positive, directed upwards, and 2g, that is negative since it is directed downwards, opposite to the positive direction. Then y minus 2g is equal to ma. The mass m is 2 kilograms. However, a is 0 since there is no acceleration along the vertical or the y-axis, since the object is only moving to the right along the x-axis without moving along the vertical axis. So y minus 2g is equal to 0, then y is equal to 2g after moving 2g to the right side, and y is equal to 2 multiplied by 9.8, which is equal to 19.6 newtons, which is the unit of the force. So in summary, we assign the positive direction of motion along the x and y axis, which is the same as the direction of acceleration if acceleration is present, or arbitrarily selected if acceleration is not present. So in this case, we chose the positive direction of the y-axis where there is no acceleration to be along the unknown force y. Then we apply Newton's second law of mechanics, in which we sum up the forces along the x-axis to find the unknown force along the x-axis. We apply Newton's second law again along the y-axis and sum up the forces along the y-axis to find the unknown force along the y-axis. So we'll follow up the same steps in part B, as will be presented in another video.